constants. They are fixed values such as numbers, letters, and strings, and are called constants because their value does not change. The numeric constants are the way you want them. String constants use the single apostrophe or the double apostrophe. You can see here an example. Print 123. 123 is an example. It's a constant. Or print 98.6. It's a constant. Or print hello world. This is also a constant, but it's a alphanumeric or a text, and it uses apostrophes, the string. There's a small glitch here, which I'm not sure what it is. I'll just delete that. Right, so a variable is a name place at a place in the memory where a programmer can store the data and then retrieve that data using the name of the variable. It is up to the programmers to choose the name of the variable. It is possible to change the contents of a variable during a subsequent assignment. So for example, at the beginning we have x with a value of 12.2 and y with a value of 14. Then we can reassign a value to x to be 100, and then x will change to that 100 as a value. Some of the rules for naming Python variables are it must begin with a letter or an underline. It cannot begin with numbers. It can contain letters, numbers, and underlines. Are sensitive to the shift lowercase to uppercase, lowercase. Some of the good examples are, for example, spam, eggs, spam23, underscore speed. Bad examples are 23 spam, hashtag sign, var.12, and there are different. These are different basically. So lowercase spam, uppercase spam, all uppercase. So just first letter uppercase. They are different variables. Some of the reserved words which you cannot use as variables, you cannot use as identifier names as well. It's the words that are in this list, so and, del, for, is, raise, assert, elif, from, lambda, return, break, else, global, try, class, not, except, if, or, while, continue, exec, import, pass, yield. That finally imprint as with. So you cannot use these ones to define a variable. So the assignment instruction is x equal to. Assigning as an expression is x equals x plus 2 or y plus 2 or another variable plus a number, or it can be text as well. And the instruction print, to print on screen, is print x. However, this form print x is for Python 2.7, so it's not useful for Python 3. From Python 3 it changed, it has to be within parentheses. Assignment instructions. We assign a value to a variable with the assignment statement, which is equals. An assignment statement consists of an expression on the right side and a variable to store the result. X equals 3.9 multiplied by x multiplied by 1 minus x. So x will get the value of the entire mathematical equation in that after the equals. A variable is a memory allocation used to store a value. So, for example, 0.6, x receives 0.6, which is stored on the hard drive, in the memory, with that value. So there is an expression, which is an equation on the right side of the equals. After it is evaluated, the result is assigned to x. The value stored in a variable can be updated by replacing the previous value. So 0.6 can be replaced with 0.93. So x will no longer have the value 0.6, but it will have 0.93. Due to the lack of mathematical symbols on computer keyboards, we use computer dialect to express classical mathematical operations. The asterisk is multiplication. The exponent is elevation to power, is represented differently than in mathematics. So plus is addition, minus is subtraction, star is multiplication, backslash is division, double stars is squared, and percent is module. So the variable access here, xx, that gets 2. And then if we assign to xx the value of xx plus 2, we will get 4. As you can see also, I can demonstrate here. So let's say that xx gets 2. And then we want xx to get the value of xx plus another 2. And then we have to print xx. As I mentioned, we have to do it in parentheses because of the difference in values of the Python edition. We can do the same with other variables, as you see here. With y and z, it's just the difference in the name of the variable. So, for example, for multiplication, we have yy equals 440 times 12. We can also say tell Python to print the entire operation. No. So we cannot do that. We have to first give it the instruction to create the variable and then to print that variable. We can do division if we want to divide yy to 1000 and then print. If you forget to put the parentheses, you will get missing parentheses in call to print. So Python will tell you what is the error that you have made in case you get any error. So we get 5.28. This is because this handbook has been created for Python 2.7. So there's a difference. And we get the decimal values as well in Python 3, after Python 3. Okay. If we want to get the module, we create a variable, and then another variable which gets the module of the previous, and we print Right, I wanted to show you if you write like this, it gets an error because kk is not defined, so it's case sensitive, as I mentioned earlier. Name kk is not defined means that that variable doesn't exist. We can also print 4 to the power of 3, which means 4 times 4 times 4, and the value is 64. Okay. Valuation order. When we use multiple operations in the same equation, Python must know their processing order. So this is called operator priority. Which operator has priority over others? This is like mathematics. Or is it? The operations priority rules. Rules from highest to lowest priority. Parentheses are always respected. So first is parentheses, then is the exponent or elevation to power, then is multiplication or division and rest, and addition and subtractions from left to right. This is the order. This is the most important, parentheses, and then elevation to power, exponent, then multiplication. So for example, and x equals 1 plus 2 to the power of 3 divided by 4 times 5. The first result is the elevation to power, which is, we'll give an 8, and then it's division, so 8 divided by 4 is 2, and then is multiplication, 2 multiplied by 5 is 10, and then is addition. You can see this if I also do it myself. So x equals 1 plus 2 to the power of 3 divided by 4 times 5. If we print x, 11, exactly the same as in the slide. Remember the rules from top to bottom when you're writing code. Use parentheses and keep the mathematical expressions simple enough to be understood. Decompose long series of mathematical operations to make them more readable. So in the previous version, in 2.7, the division would truncate the decimals. So 10 divided by 2 equals 5, but 9 divided by 2 equals 4, even though it's 4.5 that we know. The floating point division produces floating point numbers. For example, 10.0 divided by 2.0 is 5.0, 99.0 divided by 100.0 is 0.99. So I can show you this the difference, because I also have Python 2.4. Let me see if it starts. So as you can see, this is 2.7 actually, Python. So if I tell it to give me 10 divided by 2 equals 5, 9 divided by 2 equals 4. However, if I do the same operation in Python 3.5, I get 5.0, and if I do 9 divided by 2, I get 4.5. So this is basically the 3.5 edition is in a way better. It gives decimal results. Right, so if you are using Python 2.7, you would need to give 9.0 divided by 2.0. or even just write 9 points divided by 2. It gives the same result. Integer and floating point mixing. When you perform an operation where an operand is an integer and the other operand is a floating point, the result is a floating point. This is due to mathematical principles. The integer is converted to a floating point before performing the operation. So 109 divided by 100, it's transformed automatically by Python to have a floating point, to have decimals. So 99 is the integer, this is integer, and 0.99 is floating, it's float number, this is the type. It gives an invalidated syntax because this is not a Python syntax, this is just to help you understand. What does type mean? In Python, variables, literals, and constants have a type. Python knows the difference between an integer and a string. For example, plus means addition for numbers, but plus can also mean concatenation for strings. As you can see here, d equals 1 plus 4. Python will give out the result 5. If you say e, which is a variable, gets hello plus there, then Python will print hello there when you give it the command to print. So let me see if I can get the hello. No, anyway. So in hello plus there, you get hello there. Of course, I didn't write a space after hello. And I'm talking about this space here. This one. It's needed to, oops. Yeah, hit enter without, I shouldn't have hit enter. Now I can hit enter. Because if I hit enter here, then Python will interpret everything that exists until here, and then it will see there's something missing here because I've hit enter and the command is on the next line, but Python will stop here because it doesn't understand what is happening there. So you don't have to have it in the same line, or you need to tell Python that you're going to have something on the next line. And I think you still need this. Nope. Yeah, this is how you tell Python that you're going to have something on the next line. So now it will do the operation that you requested. If ever you have an error like this one here, it just means that you didn't tell Python there's a follow-up of this. So Python only interprets this and it finds that there's, first of all, there's a apostrophe missing, and then it shuts down because it doesn't understand why the apostrophe is missing, and it tells you basically to correct that error. But if you tell Python that basically there's going to be something on the next row which matters for this, you can also, I think you should be able to just do, yeah, and then it will print hello, because you've told Python there's something on the next line that's important for it. To concatenate means basically to put together. Let me see why this appears. The type is important, so Python knows each type that is available. Some operations are prohibited. For example, you cannot add 1 to a string. So adding an integer to a string will give you an error. For example, cannot concatenate string and integer objects. So if we try hello plus 1, can't convert integer object to string implicitly. This means that Python will not do the work that you're supposed to do, which is convert the integer to a string. So if you want to not have this error, you have to tell Python that you want to consider 1 as a string. So writing str before the 1 means that you want Python to add 1 as a string to hello. We can ask Python for the type of something using the function type. If you want to know what type it is, because now we've changed, well, this is in case we have a variable x which has the value y. If we want to know the type of x, we type parentheses x, and it says it belongs to an int, the class type int. But now if we want to convert it to a string, so let's say x equals string of x, and then type x, x will become a string type. So it's no longer integer, it's a string now. So we can use it in operations that strings have. Because each type has some operations which are allowed by Python and some which are not allowed. Numbers have two main types. So integer is the one without with nothing after the decimal. So you can write minus 2.0, but the O doesn't really matter. Float are floating point numbers and have a decimal part. For example, minus 2.5, 98.6. Float can have double precision, which is means just it has more bits on which it records memory. Different precision. It's a bit more complicated. I will not go into details of that type. So yeah, if you want to, you can use also this command to find out the type of this number. It will say it's float. And there are other types of numbers which are variants of integers and floats. You can find out more by looking for number types in Python.